All right, this is on the back of the page you were just looking at, example 82.1. Simplify a over 1 plus a over 1 plus 1 over x. Okay, this is it's a simple continued fraction is what this is actually we're looking at. And what I want to bring to your attention is this. We've already done problems that look like that before. So let me just extract that from this problem real quick so we can just take a look at that without looking at the whole problem at once. A over 1 plus 1 over x. So we just focus on that. Ignore the a up here and the 1 plus there. And just focus on this little bit here and take a look at that. And imagine we're back in Algebra 1 classroom, because that's where we first introduced to this topic. We have a fraction inside a fraction, right? We have a main fraction bar, and we have a fraction that's within that fraction. We don't like that situation, right? So a is not a fraction, 1 is not a fraction, 1 over x is a fraction. So the issue with this problem is that this fraction is in the denominator. We don't want that to happen. The only fraction there is 1 over x. Its denominator is x. So if I multiply times x, and times x, every single object gets multiplied by x. This fraction that's right here, that's been brought over here, becomes, here's my main fraction bar, there's the plus sign on the bottom, a times x on top, x times 1 on the left side of the plus sign, 1 over x times x makes plus 1. That fraction is equivalent to that fraction. Okay. If I do that step and then I put it back into the problem, so again, I took it out, I fixed it, now I'm going to put it back in. Watch what happens. This a is still a, this 1 plus is still 1 plus, because we didn't do anything to those, right? And this blue stuff that's boxed in here became ax over x plus 1. So I took the ugliness of this problem here, took the ugliness out, fixed it, put it back in. Now I got this problem that's still not very pretty, but now this is prettier than it was, right? Looking at this, notice what I've got in my box there is just the same issue we had over here, right? Here's a very basic fraction. I got my main fraction bar here. A is not a fraction, 1 is not a fraction, but ax over x plus 1 is a fraction. The only fraction that we have to deal with is the ax over x plus 1. Its denominator is x plus 1. So times x plus 1, times x plus 1, and times x plus 1 is going to fix it. I'm going to create this structure, right? On top, I got a times x plus 1. That makes ax plus a. Right here, I've got x plus 1 times 1, which makes x plus 1. And right here, I've got a plus sign, right? And then x plus 1 times that, x plus 1 cancels x plus 1, so I get plus ax. And just like that, I've got a simple fraction, non-fractions on top, non-fractions on the bottom. That's the right way to do it. It works every time, never fails. Students who do it this way get the right answer almost every single time. I say almost every single time because occasionally, just like I showed earlier today, 3 times 4 might equal 3 because you forgot to do something. You forgot some number was there. Or maybe ax plus 1 makes ax plus 1 instead of ax plus a. Maybe you forget to distribute, something like that. That kind of careless mistake happens. But more often than not, students do this, fix it, put it back in, and work it out. They get the right answer. Okay? The other students that try and come up with shortcuts for this get the wrong answer 97% of the time. I made that statistic up, but it's pretty close. Almost every time they miss it. It never fails. So do it this way. That's my long and short of that argument there. Do it this way. More often than not, you get the right answer. Try and shortcut it. More often than not, you're going to get the wrong answer. This is the way to do it. That's all the work I'd expect to see anybody.